Are you asking on the bananas that were taken out by the moles?
Yeah, exactly.
Yeah, that's a challenge that I have. You see, in my system, actually my farm, I have noted that there are parts which are mostly infested by the moles, and actually these parts have come to realize that they are not dominated by termites, and by termites I mean that the moles and the termites do not auger well. For you see, the mole is a burrowing animal, and also termites have nests underneath. So at the lower part of the farm is the part that has been mostly affected by moles, because there is no food for termites there. And the only food that I feed the termites with is the organic matter that I bring in. But on the upper part of the farm, upper part of my farm, I have a very large system that that is actually my second system. And I find that that place underneath there is the nest for these termites. And once I continue adding the organic matter, I find that yeah, and obviously we know that these animals have their own instincts, their God-given instincts. So moles have not infested my upper part due to the fact that there are these termites which are now have become my accomplice in the farm, because the moles have been chased away by the termites. And you find that these bananas is what the moles find it easy to attack first, because they are very light, they are very soft. And now I've devised a way of now growing the wild banana, because there are several varieties of bananas. And this wild banana has a very, let's say, a bad taste, because it's wild and it takes like 5 years for it to produce its first bunch. And once it produces its first bunch, it eventually dies. But again, over these 5 years, I know that once I plant it on my system, I shall have a good source of biomass, because even the leaf area, the foliage of these wild bananas, they are very big. So I'm actually fighting two birds with one stone. The moles cannot eat the wild bananas, and the wild banana will provide me with biomass.
And it will invite the termites on their turn. Biomass,
Sorry?
the accumulation of biomass will invite the termites. The termites will chase the moles away. A nice example, better example we cannot have, of accumulation of energy. The syntropic means, eh? So if we accumulate the biomass, the woody material on this farm, then the termites will come to decompose it. And while they come to decompose it, then the moles, they should be chased away by the termites. So the problem has been solved by one of our managers of the system, the termites, co-managers, I should say.
And then another thing with the maximization of photosynthesis, when the sunlight is trapped, the plants will be making the food, and then they will be broken down like the sugars. The energy will be formed. So the plant will be exchanging this energy down there with the nutrients, for the microorganisms that are down in the soil. So that's why we'll be doing that. And again, when the sun, when it is not raining, it is that hot. At night, there will be an evaporation of that heat or the water. Then during that evaporation, some of it will be trapped by the leaves, causing condensation of that water, and then it will come back in the morning. We'll see something like dew. Seems like the secondary rain.
Yeah, I have a question. This is Brechtje. Just for my understanding, what is the difference between maximization of photosynthesis and stratification?
Okay, maximization of photosynthesis. As we all know, photosynthesis is the process by which many sources of energy and sunlight is transformed, like the sugars, oxygen, they are transformed into nutrients or into oxygen. So with us human beings, we are taking an oxygen as a byproduct, then the nutrients will go to the crops. But when you come to stratification, we can describe it as the technology, or rather a way of achieving the maximization of the photosynthesis. That is the stratification.
Just next to the tamarindo, there is the mother of the forest. And right below it, there is a timber tree. This is a Gravelia robusta. And right below there, you see the principle of stratification. There is the coffee here, which is low strata. So,
Very close to each other. Nice.
very close to each other. Yeah. So we have this coffee as a low strata. We have a high strata, which is this timber tree and also a biomass accumulator. Just below there, we have this castor. And very next to it, there is this lucina, the nitrogen fixer. And below there, we have a mountain pawpaw. These have just been planted to maximize on space. And there is an amaranth right there. And another, this is a mountain, no. This is a wild banana. And also I became adventurous enough and added more vegetables. This is a kale down here, and I have this celery. This is my insect repellent. And just backing up
What is
again.
mountain pawpaw?
Yeah.
Sorry?
What is mountain pawpaw? I don't know the plant.
Mountain papaya.
Okay.
The
Thanks.
papaya variety that can tolerate more cold. Because mostly papayas are heat-loving plants, but the mountain papaya can tolerate more cold.